So, Pavel, you can start.
Yeah. Hi, guys. Do you hear me well enough? Yeah, unfortunately, I can't hear anyone, but I hope that everything is, you can hear me clearly and everything's okay. So, I have two presentations for you for today. First one is going to be simple enough and short. It's all about one more or less trivial idea which may make your life as a developer a lot better. And the second one is huge, and there are a lot of open questions, and there are a lot of future references. So I will try to go quickly through the first one and reserve more time for the second one. So first one is about structural logging. Sorry. Hold on. Yeah, it seems like that Zoom is kind of blocking my input. Just a second. Okay. No. Okay. So it works now. So I guess everyone would agree that we need structural logs. When our logs aren't structured, it's kind of hard to aggregate them, it's kind of hard to process them, and so on. So in our modern world, when all the systems are distributed and we are dealing with multiple instances of multiple applications, running on multiple machines in different data centers, we usually want to aggregate logs and process them. And there is a dilemma. So in case we just write logs and as we get used to, in case we just emit strings, it's convenient for us to do it. But when it comes to aggregation, we have to use something like regular expressions to extract some structure, to extract some values out of there. So we have an alternative option. We may prepare some structured messages and emit them and save into some kind of a structured log storage slash document database slash whatever else. But usually it's just not convenient for us to do it. As well, there are some issues with almost all the modern logging frameworks we get used to, like usually they promote some non-solid approaches. I guess some people may tell me that solid is deprecated and outdated, but it's a subject of it's a separate question. And in general, solid is a good and sane set of recommendations which are worthy to follow, and so on. So let's consider two trivial examples. So first one is the Scala logging API. Scala logging is a library by Lightband, X-type safe, and I guess all of you have seen it, and most likely almost all of you are using it at the moment. So here you have your login event, and you have just a string. Which is easy to write, but unfortunately, here we are losing our structure. It's a fact. As well, this lazy logging is a dirty singleton, which is invasive. It spreads as a cancer across all your code. Moreover, you have to keep in mind that it is effectful, so it promotes bad practices from both object-oriented and functional programming points of view. So, and here we have another example. It's a typical example of structured logging API. So you have to prepare some structure when you have to call your logger, and indeed this thing it would be convenient for a machine to process, but usually almost all the people they would prefer to avoid such things unless we feel that it is really required. Yeah, here we have another kind of invasive magic ritual, which isn't solid, which is based on some kind of singleton factory. Sorry. It's kind of inconvenient to get an instance of our logger. So that's what we get used to. But let's think a bit. So we have a simple Scala snippet. And this is how a typical logger event looks like. Main worker method providing a string interpolation expression, catching some values from our context, right? Right. But this is how it looks for us, for programmers. For our compiler, it looks a little bit different. Here is our syntax tree. Look at it. So I have our interpolation expression here. We have our variable names here. So in case we have an access, in case we have an access to syntax tree, we may extract the structure out of it. So the code is always structured. We have argument names. We have static information about our context, like when compiler knows in which file, on which line an expression has been typed. We know interpolation context. We know the dynamic part of our expression. We know variable names and so on. So theoretically, we may just write a macro, which would extract all of that information for us and pass it to a logger. And here is a snippet which shows a signature of such a macro. So we did it. We have implemented a login library which allows you to have structured logging messages for free, and it's a nice library with a lot of features. So let me quickly tell you about them. So at first, it's very tiny. The core has no external dependencies. It performs all the context extraction during compile time. So we don't need to process stack. We don't need to do anything else. We are trying to do everything we can at compile time. We provide you console and file syncs. We support log rotation. We support asynchronous logging. At the moment, it's just a single thread, but in case someone needs more, it's not an issue to implement it. We have string and JSON rendering out of the box. We can compute structure identifiers, and this is the important thing. I will tell you. I will explain it. What is it later? The library itself is modular, so you may implement your own syncs, your own routing logic, and you may just take the macro and reuse it in your projects in case you aren't happy with the rest of the library. It it does not rely on any kind of dirty singletons. It doesn't use class path scanning. It's completely DI ready. It provides a method level granularity, so you may set different options for different methods in your classes. You aren't limited. You aren't limited to class level loggers only. When it is integrated with SLF4J, so we may pick, you may replace logback with our library and everything would work. We would pick up all the messages emitted by code using SLF4J. Of course, we wouldn't be able to extract structure, but at least we will be able to route them. We support user-provided logging context. It's another interesting concept. It's something similar to MDC, but I will show you it later. And we have a nice and convenient feature which may help you a lot. We are inserting hyperlinks into our console messages, so you may just click on that link and get in your IntelliJ or Eclipse console and get right to the logging line emitted. So here is a snippet showing you how does it look like. So on line 5, you may see a simple login expression which just takes 2 arguments, and you may see corresponding console output on the first line on the screenshot. When sometimes you may wish to pass an expression as a login argument, and in that case. We provide you an opportunity to define a name for such an expression. So on line 6, you have an expression with a name assigned. So and you may see how does it look like on the screenshot. So instead of showing you the whole expression, we are showing you the name. Just in case, I have to mention that in case you don't use this syntax, we would show you just the last part of the chain. So it would be next int instead of the whole expression. In cases when we cannot process, in case we don't know how to treat an expression, we would show you the tree. It's not nice, but that's all we can do. So on line 7, there is another syntax allowing you to hide arguments from your console output. Of course, they will be preserved in structured output, but it allows you to format your logs better. In some cases, it is required. And there is one more interesting thing: a user-provided context example for on lines from 8 to 10. So, what is user-provided context? It's a static part of your logger context, which has been added into each log call. So, in case you have a logger, you may create a sublogger, providing several values to it. And these values would be added into each call you made with your new sublogger. So on the last line on the screenshot, you may see how does it look like. So I've provided 2 values, user ID and company, and these values were added to my to my log message. So pretty cool, right? I can't hear anyone, but I hope you agree with me. So, but that's not everything. We have something nice for our machines. Here you may see how a first log call from this snippet from line 5. How does it look like? How does it look like when it's rendered with JSON policy? So we have our arguments extracted. And you may notice that we normalize names. and you may notice that we are aware of some types. So here I have a list, JSON list instead of string representation. And moreover, that list itself is typed. So there was a number. It was a list of any containing different instances of different types. And here you have a number used for type used for number, and strings are used for strings. When we have logger context, so here we have file, line, we have standard information like thread name, we have logger level, we have timestamps in both formats, in format of Unix timestamp as an ISO timestamp, and we have logger name, as you may notice. Here you have method name. This is usually you don't have it, and it might be convenient in case you want to alter login setting with just for one method. When we have message template, and we have rendered messages added here as well. So, what's such a structure? It is definitely lots easier to process. Such structures are a lot easier to aggregate and so on. And here you have one interesting thing: class, event class. So I guess you already you can already infer what is it. So technically, it's just a hash of message template, but semantically, it defines a message class. So all the messages produced with by the same template will have the same class. And it's very nice because you may use this class value for example metrics, like in case you want to know how many times a logger event has occurred, you may just filter your database against this value. And in general, it makes your queries against your database easier. You don't have to take care of the whole message template, copy paste, and so on. You have a short identifier. So that's it. What's the current status of this library? It's ready to use. We are using it in production, in real production, for 4 months. It works. There weren't any serious issues with it. Some things are still not ready, like at the moment you cannot define logger config as some kind of a static configuration file like you can do with logback and other things like log4j, but we are going to deliver it soon. When we are going to start using log events to collect metrics and provide some APIs and integrations to simplify that. And in general, it may be a good idea to clean up the library a bit and do some refactorings, but as I said before, it's ready to use. You may try it already. Just start the dependency and replace logback. So that's it for the first speech. Thank you for your attention. Now feel free to ask me your questions in case you have any. And then let's move to the second speech. Guys, is anyone there? I see. Yeah, I see you.
Hi, Pavel. So, can you hear me?
Yeah.
So just we have, I'll ask base questions to Telegram first.
Mm-hmm.
So if you have any, if you have something, so you can see there, or if someone locally wants to ask, I'll pass it you to the chat.
Okay.
Okay. So far so good. I think we have more people now.
So let's move to the second speech, or
yeah. I think we can just move straight to second, and then.
Okay, so I'm just curious. What is the perception? What people think? Is everyone happy with what you've seen?
I don't know. There's no discussion, so it's pretty calm at the moment.
Okay, fine.
So people are just focused on the talk.
Okay, let's talk. Okay, let's continue. So, I brought one more subject to discuss.
Okay, so I'll just pass you. Yeah. Okay.
Yeah.
All right. So I'll turn off my microphone for now.
So, as I said before, I have one more subject to talk about, and this one is big. Some things are opinionated, some things are questionable, and so on. And most likely we wouldn't be able to discuss everything today. So in case you have any open questions, I'm always available to talk, to chat, to answer, and don't hesitate to ask me, argue, and so on. So, as you may read, it's about rules, a viable alternative to microservices and monolithic design. So, everyone, I think, would agree that monoliths are broken. And usually people criticize monolithic design because it provokes people to write tight-coupled, non-solid code, and very quickly your code base grows to a state where it's not worth to maintain it. As well, there are some operation issues like when you need to deploy, you need to deploy everything. Even when you change just one line and one component, you have to rebuild everything and deploy everything. But in fact, it's not always a bad thing, and I'm gonna talk about it a little bit later. When usually, this is a discussable thing, but usually startup time may be high for monoliths, especially when you don't design properly. It may be inconvenient to maintain huge monolithic code base. It may be inconvenient and to rebuild everything after each change. And of course, you have dependency convergence issues, like when you have two dependencies, you transitively brought into your class path, and these dependencies are incompatible. You are fucked. I have to mention that in general, proper structuring, strict coding conventions, and different enforceable boundaries like artifact level isolation, like linters, like at the final end, pull requests and reviews, they may mitigate some issues. Usually people say that we may fix a lot, 50% of monolithic design issues just by pulling conservative parts out of our main code base into independent libraries. Right. But still, we aren't happy with monoliths. And we have microservices as an alternative. Microservices we are addressing some problems of monoliths, like they put strictest possible isolation on software components. They are running in different processes. Convergence issues are addressed by that level of isolation as well. It's usually they are easier to scale, especially in case you design properly, but usually it's hard to understand what does it mean properly. And you may redeploy independent components and so on. And moreover, you have some benefits like you may hire different teams using different stacks to work on different parts of your project. But I guess everyone has seen this. This is an old joke, but it didn't appear out of blue. In case monoliths are broken, microservices were just sick. At first, it's all about dependencies. When you have a microservice which depends on another microservice, it always creates a lot of pain, and this pain grows. And usually we can't get rid of cross-service dependencies completely because we have some shared state. Sometimes we can avoid it, but usually we can't avoid shared state completely. And the worst case, or very common shitty case, is when we have two services with one shared state, and we have two more services with different shared state, and trying to get rid of this state or make it controllable. Usually people come up with a star design where we have a huge monolith at the center intended to manage all the shared states, all the possible shared states, and a lot of simple stateless minions around that monolith. Not the worst design, but it kind of kills the idea of microservices. When deployment and maintenance they become more complicated with each new dependency, like in case you have two services and they depend on each other, you may and one of them is dependent on another. You may have to deploy them in the correct order. And you may need to ensure that some predicates are satisfied, like a service has opened the port or did something else, and only after that you may start next service. It's okay, it's discussable and we have something to address these issues. Let's talk about it later. But once we choose microservice way, our system becomes distributed. And distributed systems, they have some fundamental problems which you cannot avoid and which you cannot get rid of. You may choose some workarounds, but you can't get rid of them. So usually people, when they go microservice way, they don't try to think what is my system, what are characteristics of my system according to CAP theorem. Usually people think, okay, some people think that CAP theorem it applies only to databases, but in fact it applies to all the distributed systems. So you have to think carefully about timeouts, about consistency, about retries, and so on. And when you have cascading failures, like in case a service is broken, all the dependencies of that service are broken, and sometimes you can't even detect it properly. When It's easy to get accidentally get into a state where components of your system are not compatible, and sometimes it's possible that you wouldn't notice such an issue till your code get to your production. And this is amplified by cascading failures as well. So a typical example. Someone made a quick patch to fix some kind of an issue when deployed it to production, but that patch, it affected, for example, data structure. And you may not notice it till the first call. And another example is you have a queue filled by your messages, so you deployed a new component with a hotfix, and that component cannot pick up messages from that queue or fills another queue with new messages our services cannot parse, and so on. Well, next issue is computing density. So when you want to run 50 microservices running on JVM on a single machine in Docker, most likely you wouldn't be able to do it. Sometimes you can, but usually you can't even deploy, 20 services on the MacBook, for example. At the same time, again, very often, these services, they may run on a single machine. They may use single heap and so on. You can't run them just because of the isolation level you have, and it makes your development flows overcomplicated very frequently. So it's a typical case when a simple integration test requires many things to be done in right order, and it takes a lot of time to set up a test environment, local test environment especially, just for a quick test. And then once you made your test, you need to spend more time to deliver a change into your test environment. So isolated environments, they may, and usually they are expensive to set up, and because of that, people very often they come up with just one or maybe several development environments maintained by operations people, and all the experiments and tests made against these environments, they may interfere with each other. So it's reproducibility of your work, of your experiments, of your tests may drop significantly just because of operations issues. Also, I have to mention that integration test is not a good constructed definition. Like it's a subject of separate talk, but in background you may think, in case you have a test which tests just a single class, a repository, which interacts with a database. Is it a unit test, a functional test, or an integration one? So we may make a short summary on microservices. Software components are still in place, just in forms of services, and all the potential pitfalls of component design apply to microservices as well. So microservices, they don't solve bad design issues. Their primary purpose from design perspective where primary purpose is to put strictest possible boundaries. But just boundaries don't solve issues. Just boundaries wouldn't allow you to think better in case you don't try to think. And when there are other issues like many checks which may be done by your compiler in case of monolithic design, like with structure compatibility checks, they have to be performed on integration test level, and it's good for you in case you have good integration test suite, but we all know that it's a pain to write good integration test suites. And because of fundamental distributed systems problems with tests, it's a lot harder to make them reproducible and reliable. When we delegate many tasks to operations, like in case of a monolith, our dependency graph, our components are wired together with our dependency injection framework or a mechanism of the same purpose. In case of microservices, in worst case, our dependency graph is processed by people and some crappy bash scripts. In the best case, it's processed by an orchestration tool, but there are some issues with orchestration tools. In fact, we still don't have a perfect orchestration tool. You may point me at Kubernetes, but Kubernetes isn't great. It's one of the best tools available on open market, but it isn't great. It's full of problems, issues, bugs which aren't closed for years, and so on. And keep in mind, your DI framework does exactly the same job as your orchestration tool. But of course, your orchestration tool, good orchestration tool, would do a lot more things. But in case we forget about processes, services, in case we think in terms of components, a huge part of orchestration tool responsibilities is to do the same job DI frameworks do. Resolve and wire dependency graph. So, in general, we want to have something, we may want to have something with all the positive traits of microservices and monoliths, but with less disadvantages than both of these approaches. So, what may we do? We might try to combine our services back into a monolith. Okay, it's not true, back into one process. And let our user choose which roles he wishes to assign to a process before he starts it through command line. So, a role is is a software component living in your class path, which may be discovered dynamically or statically, it doesn't matter, as just a software component, a class. Available for your app to discover and run. This idea resembles containers, like web containers, like Jetty, Glassfish, Tomcat, and so on. And of course, this resembles OSGI, and all the containers we built on top of OSGI, in fact. In case someone didn't hear about OSGI, it's an old thing, open source gateway initiative. It's a set of standards allowing you to write modularized applications and rewire them dynamically. We may talk about it separately. At this point, this is enough. So containers, in general, containers are nice, but they have a lot of disadvantages as well. First, a container is a platform which provides you a lot of components, services, and options, and usually they are very slow on startup. It's always a pain to redeploy an application to a container. And there is a company named JRebel which made a lot of money just by implementing a tool which is reusing standard Java capabilities to redeploy, quickly redeploy applications onto the containers just for development purposes. When containers, they are based on isolated class loaders, and isolated class loaders, they are nice because they allow us to solve dependency convergency, all the dependency convergency issues, but they are inconvenient. Moreover, OSGI itself is a dynamic dependency injection framework, so it supports component life cycles and allows you to rewire your application on the fly. So you may stop a component and replace it with a different version. But many people who get exposed to dynamic DI, they describe it as a nightmare. It's not something you want to use in your everyday life, but some people may argue. So let's get rid of the dynamic DI idea, and let's get rid of, or at least keep it and keep isolation optional. So this is how it might look like. You have one Docker image containing one binary, allowing you to run all your components in a single container, in a single process. And for your development environment, you may start all your components, all your services in a single process. And for your production environment, you may use the same image to implement a typical microservice design, but with some improvements. Like in case you have a set of services with a low load profile, you may run them in a single process, having a single replica. And in case you have a component with high load profile, you may set up as many replicas as you wish behind the balancer. So such an approach, it has a lot of benefits and some issues, of course. At first, you have to note that roles allow you to do everything you can do with microservices. Roles allow you to have the same flows, exactly the same flows as you have with microservices, but as well you may have some additional and very important benefits. At first, you have a lot higher density, and it makes your development flows better. You may instantly start on your developer machine in your test environment any combination of your services without taking care of their orchestration. It's going to be done by your dependency injection framework. It makes operations easier because you aren't limited by the idea of one component per one process per one container. You don't need to start 5 containers to have 5 services with low load profile. You may start just 1 container with 1 process. So altogether, you would have to deploy less containers, use less virtual machines, and consume less resources. As well, you'd achieve a smaller distribution size, and it may be important in case you have a huge, environment where you redeploy components often. When you'd have more static checks, so it would allow you to achieve higher reliability. As I already said, it would be easier to set up test environments. In general, you'd have to just run a process. It would be easier to perform integration testing, and then the final one, you would achieve the same things. Higher reliability and quicker delivery, and you might achieve quicker builds. You just have to understand what roles they don't solve all the issues automatically. It's not a silver bullet, it's just a flexible way. You may consider it as a flexible way of doing microservices, more flexible than microservices are. So, and of course, there are some obvious and non-obvious pitfalls, like we can, in some terms, we come back to monolith. So a monolith with strict boundaries. So our startup time may increase again. Design matters. We have to design. We have to design properly in order to have good startup time. We have weaker isolation. So a failure, like, I don't know, system exit call or out of memory exception, would affect more components, and it wouldn't be isolated. You may mitigate some failure isolation issues, but not all of them. And this is a fundamental thing. When dependency convergence. So in case you don't have isolated class loggers, you have your dependency convergence issues within your monolith. In case you do, it may be inconvenient for you to work. So this problem, as I said before, it is addressed in OSGI in the best possible, in the best way possible, but it's still not nice. So when, of course, you cannot fit one heterogeneous system into one process. You cannot mix .NET and JVM code in a single process. But if you use role-based approach in your heterogeneous environment, you still may significantly improve your flows and simplify them. When roles themselves, they don't address any issues of distributed communications / RPC. In Java, most likely you wouldn't want it, because in case you have a role which needs another role, you would just inject it and have it running in the same process. But in case you want to be able to do distributed calls and transparent distributed calls between your roles deployed on different machines. So in case you want to have call transparency, you'd have to follow some rules, conventions, and most likely you would have to build a distributed dependency injection framework built around service discovery and cluster state concepts, something similar to DOSGI, distributed OSGI. And you may need to build a nice continuous delivery pipeline which would take care of component versions, which would have dependencies between different parts, between builds of different parts of your product. So at this point, yes, as well here, design matters. Design always matters. We have something. We may show you about design, about continuous delivery, and other stuff, and it's a subject of separate presentation. So we have a tool. We have a dependency injection framework, which allows you to have roles almost for free. I can't talk too much about it. I guess yeah, my time is almost over. I have just 15 more minutes. So I will make a quick walkthrough, and that's it. So our DOI framework, it's built on generative programming approach. It's built around late binding principle and a pattern we have invented. It's named plan, percept, plan, execute, repeat. It allows you to plan your all your context provisioning operations when edit that plan, when executed. It may sound odd or irrelevant, but again, it's a subject of separate speech. Our framework is completely aware of Scala type system. It supports higher kind types, so it allows you to use all the functional tools and approaches you use at the moment. It's very convenient to use with Douglas final approach, and in general, it allows you to fuse functional and object-oriented programming a lot better than you ever seen before. Yes, it was a marketing bullshit. When it has bundled garbage collector, so we solved typical dependency management problem in a very nice manner. You don't have to take care of dependencies, unnecessary dependencies between your components, because you have garbage collector. And we have just in case garbage collector is built as an extension for the base framework. And then we have roles mechanism, which is built as another extension, and it is cheap for developer as well because it's completely relies on garbage collection. And we have integrated support for type-safe config, and it's just another extension for the framework. And I may say that maybe it's another bullshit, but once you start trying it, it may feel like a new paradigm. There are a lot of patterns, a lot of possibilities we are still discovering and documenting them. Moreover, some patterns at one point we are rejecting them because they may be kind of an anti-pattern. So it's altogether it's a very interesting subject, but it's a subject of separate speech. So here is a simple example. Just in case, it's almost this code is an almost working example, which shows you how it might look like. So here you have a service. A service is just a component, just a class. Hence, taking some constructor arguments and defining its name visible for the user, just in case this is the only point where you need an annotation. As you may notice, this class it is parameterized by a higher kind of type, and it's there is a type class associated with it, so it looks like a functional code, right? When you have a declaration saying that you wish to have this service, you wish to this service to be available as a service. And here you have IO as a class, as a type parameter. Just in case it's not necessary to have all your declarations concrete, you may just accept type argument here. Test plugin may accept arguments, and they support that. And then you may just have a launcher and tell it which services, which roles you want to have up and running. This example, it assumes dynamic component discovery, but we support this. It's not necessary to use this approach. You may just define a set of plugins you want to use in your launcher and save some time, couple of seconds on plugin discovery. I have to say one thing. This API isn't published yet. We are going to publish it, I guess, by end of Monday. I wasn't prepared this event to happen today. I thought it's going to happen on 12th of August. But we are going to deliver this part as soon as possible. Yeah. And here, I don't know, can you see anything here or no? It's a screenshot of a real app having several roles, running from a Docker container. So here I said that I want to run one rule. Here my app starts, initializes, shows you component versions and git commits associated with each component. And this is an important thing. All the roles were in separate repositories. So here you have a set of roles which are available to start. The app tells us that it chooses just one role to start, and here are some initialization logs. That's it. So the framework itself is ready to use. All the parts except of role API, we are available on GitHub. This thing is in real productions for 4 months as well. We are gonna implement roles. We are gonna make roles as soon as possible. As well, provide some kind of a test kit. And we are thinking about supporting optional isolated class loaders in foreseeable future. In case you're interested, you may check our GitHub. In case you are not, you may still consider this pattern as an interesting option you may use in your projects. It's not necessary. It's not necessary that you may like our code and our library, but most likely you would like the pattern itself. And the framework itself. I see the questions. I will answer them. Once I finish. So the our DI framework and our role mechanics is just a part of our stack. So we have a vision how a proper delivery process and development process should look like. And we have tools which back our vision. So we have We have an RPC framework. It's a gRPC alternative with rich and nice modeling language, 100 times better than protobuf, and it's transport and codec agnostic. So you may choose HTTP transport, WebSocket transport, or whatever else, and implement your own codecs and transport if you wish. We have zero-cost structured logging framework. We have already considered it today. Then we have some guidelines on what we call functional programming and design. So as I said before, we love both functional and object-oriented programming, and we have some ideas how maybe do it properly. It's a subject of another speech. And we have some guidelines on continuous delivery process specific for role-based approach. And we have a thing. We have that percept, plan, execute, repeat generative programming approach, which consists of a very specific computational model and abstract machine, which are addressing complex issues of project planning, which is part of operations research discipline. Initially, this thing has been invented as an answer to design issues with Yandex orchestration tool named Interstellar Spaceship, which I've implemented. But when we discovered that it may be applied to many different areas, like build systems, like DI frameworks, like robot homeostasis, and so on. And altogether, these things already allowed us to significantly reduce development costs for our customer. You wouldn't believe, but even at this point, a typical mid-sized software development company reduced its maintenance costs for 50%, and this is just a conservative estimation, and it's just a beginning. It's just the beginning of our transformation of that company. So I hope it all looks interesting for you. Thank you for your attention. In case you have any questions, feel free to ask now, and I will try to answer the two questions I have at the moment. So first one is, can you use roles in heterogeneous environment if they run on different processes? Yes. So in that case, you need an RPC framework, and you need a service discovery tool, and you need some kind of, most likely you need some kind of an orchestration tool to wire all the things together. But yes, you just need to have more tools. You need good RPC framework, remote procedure call, and you need the service discovery. So your roles, heterogeneous roles, may discover each other, and they have a common language to use. And this is exactly what we are doing. But as a company, I've mentioned before, almost all the backend is implemented in Scala. but they have several services implemented in Go, so we migrated these services to our RPC framework. We don't have service discovery implemented yet, so at the moment our cluster topology is static, but we are going to fix it in foreseeable future. So I hope I've answered this question. Then, is there anything special between inter-role calls? The question itself isn't clear enough, but again, in case you have two rules, in case you have two software components running in single process, obviously you may make just a direct call. You may inject an interface of your role you need to invoke and just make a direct call. In case you have two components running on different machines, you need to have some machinery in place to support such calls. But that machinery, it may be transparent, so it may look for you like a direct call, or it may be something else. But you need some additional mechanisms. So I hope I've answered. Do you have any other questions?
There's one more question, if you see my chat.
No, I don't have anything.
Okay, I'll just read it to you. So, what are the benefits compared to Akka cluster sharding?
What are the benefits
compared to Akka cluster sharding?
Akka cluster. Yeah, sure. Could you mute your microphone, please? So, Akka cluster is a very opinionated thing. While the role-based approach itself is a pattern, yes, I proposed you a tool to work with that pattern, but you don't have to use it. You may try. Akka cluster is a tool. When Akka cluster itself has some significant disadvantages. I guess you know that Akka cluster, it cannot survive brain split. So in case you lost your network integrity, your cluster may get into an irrecoverable state, and the worst thing is sometimes that state is not even detectable. So you may get into a situation when an actor can send a message to another actor but cannot receive any messages, and so on. When Akka cluster itself, yes, it is about RPC. It is about RPC, and when you use roles, you may choose Akka cluster as an RPC mechanism. Why not? I wouldn't, but why not? You may choose Akka as an RPC mechanism. But Akka does not address any questions related to microservice design or monolithic design. We have a conductor tool, very expensive and very limited in terms of scaling. When I had a chat with Lightband guys a couple of years ago, they told me that they intend conductor apps to run on in production on maybe a couple of dozens of machines interconnected with a reliable local network. And they made some synthetic tests. With 1K of machines, but in general, For some applications, that's completely fine. For some applications, 1K of machines is nothing. So while I've been working at Yandex, we had more than 50K physical hosts in 6 data centers. Akka cluster would not survive such a scale. But in general, these things were different. Rules, they are about your structuring of your code and delivery of your code. Akka is an RPC. Akka cluster is an RPC mechanism. You may use Akka cluster if you decide to try to use rules. You may use
okay. Just one don't want to interrupt, but kind of running out of time. So I think we can cut off here. I recorded the talk for other people if you want to chat. So thanks for sharing your knowledge. If you have any other questions, I guess we can just paste in the chat.
Yeah, right.
All right, thanks.
Bye.
Is everything okay?
Yeah, some people wanted air conditioning.
Yes.
It's here.
I turned off it, so it will be okay.
You turned off? You turned on?
Yes. Someone said that it's very cold.
Okay, one person.
If
it was
you
cold.
want,
Okay,
yes.
I thought it was hot.
okay, on off.
Hi. Just go can you hear me?
I can. Can you hear me?
Okay, okay.
Perfect.
So, do you want to try to share your slides?
Mm-hmm. Let's see. Sure.
Okay, yeah, I see it.
Is it working?
Yeah, it's working pretty okay.
Perfect.
So we're having a short break, but we can start in a few minutes.
Okay, just give me a few minutes. That's fine, so we can start.
Okay, I'll gather people around and can basically start. For questions, I guess I'll just paste in the chat for any questions on Messenger, or there's actually chat on the Zoom as well, whichever is more convenient for you. So for questions, is it okay if I just paste you in the Messenger?
Oh yeah.
Yeah.
Of course. I suppose the questions are at the end, right?
Yeah. After the talk.
It's important to say that the only thing that can happen is that I'm a bit sick, so once in a while maybe I'm gonna mute to sneeze.
Sure, no problem. It's fine. I don't think you're gonna spread the disease from online. All right. So let me just gather people. And,
okay, I'll be back in 2 minutes. Perfect.
Okay, sure. Okay, so we can start in a few minutes. So, are you ready? Can you hear me? Okay, so I can then just mute myself, and then I'll just give you the speaker, and then you can start.
Just give me one moment. Let me see.
Okay. Just tell me whenever you're ready.
I just noticed that when I'm sharing, I cannot see that style that I can see like notes and what's the next slide.
Okay.
How do I do it here? It doesn't. No, here they now. I'm called laser. No, it's not that. If no. Let's see what I can do. Okay, I have an idea. I'm gonna need like just 5 more minutes. I'm gonna turn on the other laptop.
Okay, sure. Will you need to rejoin or Zoom or?
Maybe I can say that you should start.
No, I had already told, but yes, some issues.
Yes.
Right now, London is hot as like no one has ever seen.
How much degrees do you have?
34.
Oh, wow. Yeah, it's very unusual for London.
Totally. Like anyone, no one is like used to that. 5 seconds.
How did you manage to get sick during the server?
I think it's because I just came back from home. I went to Brazil to take part on this conference, and over there was winter. So
okay, yeah.
maybe,
Okay.
yeah.
Climate changes can be tricky.
Awesome. I don't have a way to open it. The other laptop.
Okay. So is it something bad? I mean, maybe it's not an issue.
No, it's just because I cannot see the notes and I cannot see the order.
Okay. Okay.
The next one, but I have another idea.
Okay.
I'll think I'll upload that to Drive, so it will be saved. Okay. Okay.
Okay.
Yeah, I think I managed to.
Okay. Do you need to change your screen share or something, or not? Or you're good?
No, with the other laptop, I can keep following
Okay.
the notes. So
Okay.
I don't know
Sure.
how to do it with this one because I'm just sharing. I'm not like presenting.
Okay. So should I announce we're starting or?
Yes, we can.
Okay. All right. So I'll mute myself and then we can basically kick off. I'll
Okay.
put you the speaker.
All right, and the questions are at the end, right?
Yeah. The questions I'll paste in the messenger if there's anything.
All right.
Okay. Cheers.
Cheers.
So I already announced the weekend starting.
Okay. I forgot to ask, like, I'll be seeing the people watching, or it's already.
Yeah. Already. You can start.
Okay, sorry.
No problem.
Right. Okay. So, hi everyone. First of all, thanks for inviting me to talk to you guys about this wonderful tool that I've been contributing to. I'm Juliano Alves. I'm a Brazilian living in London, and nowadays uh, I'm working with software development for more or less 10 years. And I've been for a long while an enthusiast of open source software. And recently, the one that I've been dedicating my free time to contribute to is Quill. When I was first invited by Ivan, if I'm not wrong, we had this quick discussion about what I should present, like in an advanced level, maybe in a more introductory level. And I believe it would be interesting to talk about the theory behind the tool, because that gives you the fundamentals and gives you the fundamentals and the theory behind the tool, what takes everything to a new level, to a more advanced level. First of all, I kind of have to apologize because I'm a bit sick, so my voice can sound a bit weird, and I can sneeze like once in a while, so I'm sorry about that. It can happen. Okay, so like I said, that's my name, that's my Twitter, and nowadays I'm working for this company, Uswitch in London. It's an interesting place to work with. I'm not working with Scala. However, we have a really interesting set of technologies and interesting set of problems to solve. We are hiring, so if you're interested in moving to London, just let me know. Okay, so I like to start talking about database in the sense of, in general, I believe they are a problem for the concept of software development, in the sense of we need a different language to handle, oops, sorry, okay, all right. We need a different language to handle different technology, right? I'm not a big fan of JavaScript. I've never been. However, people from the Node community, they have an interesting point where they say that we have the same language to handle our front end and our back end. I think that's extremely valid point in the sense, right? Because in our case, and I assume that most of us, at least the ones that started coding some years ago, we started with Java, right? Most of the Scala developers nowadays are guys that suffered enough working just with Java because it's more complex. It's like an older language, right? So first moment, what we had to deal with the database was the JDBC API, right? What's quite complex, we have to send all of our comments through strings, what's extremely error prone, and it's a node solution. Like in the old times, it was the first one we had, right? Okay. After a while, we had Hibernate, and Hibernate would abstract a lot of this complexity. However, I'm not a big fan as well because I worked for a long while with Hibernate, and I really don't like what I call the Hibernate holiday. That's the biggest problem with Hibernate. You have what I call the Hibernate day. That's the day where you have to stop your project to solve all the problems that Hibernate is causing you. It has a lot more than you actually need most of time. And when you have to make something a bit more custom, you have to handle that, how's it called again? Criteria API. Or on the other hand, we have that HQL API, and not nowadays, I think JPA API, something like that, right? That goes back to the same problem where we have to handle the database with a different language again. And it has its value for the moment where, and the problems we were facing back in the day. Nowadays, I think not that much. And then eventually started working with Scala. I found Quill, right? No, it's not Quill, sorry. What's the one? I forgot now. I'm not using that for a while. That's one of the famous Scala ORMs, more or less. I forgot the name now. And when I was checking the code, like the way I was using that, and when I was checking the code, I had this feeling that everything was kind of ad hoc, more or less. I didn't feel that was like a proper solution to solve my problems. I'm kind of a perfectionist sometimes for some things, and I think that code can somehow be beautiful, and that's where Quill entered the scene, right? Quill was created by this guy, Flávio Brazil. He's a Brazilian. The name already is a spoiler, right? And this guy, he works for Twitter and is an ex-SoundCloud as well. And we have this Scala group from São Paulo, Brazil. And even though he was already living abroad, and back then I wasn't, we had like these interesting discussions, and we had like a lot of people with interesting knowledge. And back then, it started when people were discussing a different way to handle this database. And then Flavio came up with this idea that he learned from a paper. So Quill is a compile time language integrated carry for Scala. Long story short, let's making it a bit simple. it's a way to handle your database in the same way you handle your collections. That allows us to use functions that allow us to work in a functional way where we represent, we have a way to represent the data structure from our database exactly the same way we handle collections. When I think about the previous tools that I mentioned before, Quill is boilerplate free mapping, so we don't have to add a lot of annotations to our code. It can work simply with case classes. What's like one of my favorite things. I never like to add a lot of annotations and make our code quite polluted by something else. And if you take it away, it explodes, of course, because it doesn't compile anymore. Quill works with the idea of quoted DSL, and it's a shame I cannot see you guys. I would ask who between you who already know the idea of quotation, because if you work with Clojure, the macros API in Clojure, they are quite simple to use, and the idea of quotation is quite kind of clear, even though you don't want to try to do something more complex. What's not exactly the case, but anyways. Another interesting feature is that we're going to generate, we have like a compile time generation tool when we are using Quill, and in an experimental mode, you can use that to validate your queries. But then again, you can just use it thinking about that as a functional way, a way to handle your database exactly the same way that you are handling your collections, and that's where Quill can be that useful for your tooling and for your environment, the simplicity that it brings. At the same time, like I said, something that really attracted me about this idea in the first moment is this paper. That's the idea behind that. Sorry, just one moment. That was like the worst possible way to do it, to get sick. Sorry. Yeah. So I recommend to have a look at this paper. It's not that long. I think it's probably 14 to 16 pages. It's a really interesting approach, and even though it's something more academic, it's a clear explanation of the concept, and it's easy to understand, and it's quite interesting. Even though there's some how's it called, some mathematical theory, what's the name, lambda calculus maybe. It's a bit complex. I'm not into it. I don't understand that very well. Still, the concept behind that, it's enough. But the explanation in the first half of the paper, it's interesting enough to call your attention, because, like I said, the other tool that I forgot the name, it's being kind of ad hoc style. It's kind of a common project that we work in the everyday life, where sometimes it goes off of control. And Quill is based on this concept, so you can easily see how the development of that code is representing the fundamentals behind the paper. And I believe it brings a lot, because it makes sure that no one will take this tool to the wrong side, to the wrong way, and develop like add features that we don't need, and add a lot of features that will make it like really heavy and really complex. It's already complex enough. But like as a user, you don't have to worry about that. We have some plugins, but like the core concepts are that. And you should have a look at this link. It's a really interesting one. The implementation, I think, is Sharp, but no problem, right? So this paper, it has two specific concepts. The whole tool is built on the top of these two specific concepts. We have this this language figure about these two. I think they are how's it called? Greek beasts, mythological beasts. One is Scala, that's failure, and Charybdis, that's avalanche. It comes from the idea that when we are working with strings or with JDBC, for instance, when you have to handle our database like that, it's extremely error prone, like I mentioned before. We don't have any advantage. We don't have any guarantees that that query language is correct, right? Until the moment when we actually execute that. And the second one, Avalanche, it's strongly related to what happens when we are working with Hibernate, for instance. Sorry. Because working with Hibernate, commonly you want to, let's say, fetch a specific collection of items, and these items have items that have items, and they have items. And somehow we have an avalanche, like a huge amount of queries coming when we are trying to get like a specific collection of objects. And that's not what we want as well, right? So we have this definition on Quill when we are using Quill, that every single one of our queries, the generated queries, they'll be safe. They won't fail because we are doing that in compile time. And second, we won't have an avalanche because every single one of the queries you generate when we are creating our quotation, they will generate just one unique query. So it can be a big one, it can be a complex one. However, this sort of problem where we have like lots and lots of queries, aggregated queries, somehow it doesn't happen. So that's the theory behind it, right? Like I said, it has a lot of mathematics involved. You can find that in the paper, and I know it seems really complex at the first moment, but I have like a personal way to handle that, to deal with this mathematics. You can use my approach as well. I'll show you. I can represent that with a GIF. It's just that, don't think about it. It's really complex. Like a lot of people smarter than I am worked on that, and that's like their thesis and everything else. So just believe that that will take us to the place that we need, right? So first, let's consider the restrictions that this tool has. First of all, it's for one single DB. I like to think that I like to think about Quill as let's say a modern tool, in the sense of when I see people working with Hibernate and companies, it happens a lot in London. Companies saying, okay, we have our stack, we work with like microservices, and we have this quite modern cutting edge technology, and we use like Spring and Hibernate. And I wonder if these people understood the idea of microservices, because it's supposed to be small, right? You shouldn't have something that demands more than one database at a time. So Quill is focused on this direction. Let's think small. Let's think about small system. Let's think about small services. So you don't even have to consider the idea of having more than one database. So that if that's what we need, probably you should find like a different tool, and probably you should find a different technology as well. This is, I'm going to show it later on with the examples, but the idea of the quotation that I'll explain as well, it will returns a flat relation type, which means it will be a bit clearer later, but doesn't matter. In the same way that we have just one query when we are executing that, the quotation will produce just one flat relation type that will allow us to generate that query. Okay, and Quill only know operations. Like I said before, the idea is let's handle the database exactly the same way we are handling our collections. So we have that that set of data, and then we can execute operations over that set of data and produce a new result like any other collection. So going to a practical example. Sorry. We have this really simple SQL as an example. And looking at that, we have like conditions, we have a simple join, simple relations, and how this code would look like if we try to rewrite it in Scala. That would be something like that, right? So we have our conditions. Well, we have what we are looking for. So let's see. We have the couples, people and people, couples, people, where, her, him. Right? We have all the conditions. We have this. What would be the simple join? Quill offers you the join ID as well. But anyways, we have that. This simple comparations to create the relation between the tables. We have a proper one between the age, and then we're going to evaluate and get back the information we need. When we are working with Quill, this is slightly different. Like I said, we have the idea of a quotation. For the ones that never heard about it, I believe that's more, like I said before, more like a common concept if you are working with Clojure. And if I'm not wrong, it's a common concept in F# as well. But a quotation is a way you have to surround your code and postergate the evaluation of that code. So we keep that until a moment where it's interesting to evaluate that code, right? Scala doesn't provide this feature out of the box. So Quill provides you that. And it will change a lot your code. Pay attention. You have to do that. And now we have the definition of a quotation. That's pretty much what we need to transform this code. Like I said, this query code will become like the SQL code the way we need, right? So now I can talk about the second restriction before, the one about the flat relation type, because when we have that, then again, a bit more of theory. What Quill does, it will get that code, and that's why we need the quotation, right? We have to be able to extract information from this code. So Quill will get this code, we'll get the quotation, and we're going to extract some information from that. And the information we have is like any programming language, we will define our AST, analytic syntactic tree, because the idea is we're going to pick up this code, we're going to extract the information we have, we're going to flatten that, we're going to put it in a specific order, that we can translate it later on. So this code will become something like that. I just like put it together. But here we have like a lot of definitions of what that code would be according to the AST defined in Quill. This is a bit complex, but I invite anyone to go and check it out, the code on GitHub. It's really interesting because it somehow, I mean, one of the interesting things for me that it has always been like that to handle software, open source, is the fact that we are dealing with things that we don't do on our everyday jobs. So this concept, this AST, is something that usually we study during university at the topic of compilers or interpreters and something like that. And suddenly we actually have to learn a bit more about that to understand how you can contribute and how to improve your own skills related to ASTs. So then again, if it's a bit complex at this moment, just trust me. But like this code will somehow generate this structure of elements, okay? And what would be the next step? Well, we have the Scala code, the promise of having of handling your database the same way as your collections. You have this flattened structure, right? And then we have the mathematical theory behind that, right? So in our case, what we have is that structure, that generated structure, plus the theory will generate the SQL for us. All right? That's pretty much what Quill does. Well, I don't have a. At this moment, I would ask like if you have any questions, but probably later on, right? Okay, considering that, that's what we have. Now we have the definition, we have the flattened structure, the definition, we're going to generate the SQL. I'd like to show you some of the features that are interesting when you are working with Quill. So first of all, we have abstracting over values, which means we will have, for instance, the definition of a range in that case, where this is just like a simple function, right? Where we take two ints and then we're going to query that person considering the age between, sorry, between that range. And the interesting thing is we can run that because then again, it's just a function. So Quill will manage to run that abstraction. The values, they don't mind that they don't matter that much at that moment. That's why you can postergate and just have a function instead of I don't know, any sort of definition of range, class, or whatever it is. We can just pass that values eventually, but the definition is already there. So we don't have to mind that much. It's really flexible. It's really easy to reuse this code when you are thinking about using a range or using something like that. So all the functions become reusable, and not just like that. We can postergate that because it's just a function, right? So instead of passing this value here, we can just prepare it and have the value as a separate, the list of values in a separate way. It's so hot here and I'm sick. I have to keep like drinking tea. I hate that. Okay, we can abstract over the values. We can have the functions instead of the values, right? We can abstract over predicate as well. So let's say we have the definition of a function that says, okay, we have to satisfy something here. So a function that takes an int returns a bunion, right? To filter something, or and that in our case, we can pass a function that's based on the age, or doesn't matter. You can define whatever you want, right? And then again, you won't execute that now. So the moment that you need that, you can finally execute. So the satisfies value, that's not a function, actually it's meant of. You can simply define that before, use that afterwards. Always practical, and the best part, always composable. And thinking about something that's composable, the next example is about composing queries. Sorry. So we can have like a simple query that's a query that's an age from name, right? So you pass a name, you get an age. You can have a second one. That's another quotation where I'm saying, okay, I'm passing two names and I'm getting the age of both of them. And at the same time, I'm using that previous function, range. So with the age of both of them, I'm gonna create a range between them, right? And it's simple as that. Like I said before, that's the main idea. We just have functions, you just compose with them, and everything is quite simple and reusable. That's like my favorite thing about Quill. The next one would be dynamically generated queries. So let's say instead of just define that one, just the functions, I can define a type. Let's call it like predicate, for instance, and we can define some case classes with that, like above, below, and are not quite representative. And after that, we can simply use like pattern matching. At this moment, I think for the ones that are familiar with Scala, it's crystal clear the simplicity in the sense of we are just using Scala code. Other than adding the quotation, there's nothing else we actually have to do. We have all the resource available to us. But, important to say that the dynamically generated one is slightly different because going back to the basics of Quill, when you build your query, Quill will compile that, and compile time, that will generate this string, right? Sometimes it's not possible. Sometimes, like here, for instance, we have different predicates and we have to evaluate them in different moments. If it happens, we will need the lifts. The lift is a way to, how do I say that? When you don't have the definition specific of the value, when you are not passing that specific value, we have to lift them. That will allow you to use it in your query. We'll fall back to the dynamic generation one. There's a good explanation about that in the paper that then again, I recommend. It's really interesting. So the concept is there as well, explaining for these moments where you cannot actually evaluate it now, we have to leave it, and then that will be part of the query later on. Oh yeah, it's already the example. So for the example, I just pick up like a simple example from the site, from that it's on Quill page, because it can incorporate everything from the main features of that tool. So, oops. Okay. Let me see if I can pause it. Oh yeah, I can pause it. So we have that. We have the definition of a filter. Okay, at this moment, we just have like a case class. Like I said before, we don't need any boilerplate code. We don't have annotations. We don't need anything else. We just have the person. Then we were defining this quote. We have the query saying, okay, we are filtering on these specific parameters, mapping to say, okay, I just want that one. And here we have one of the experimental features that shows you what's going on. So remember, it doesn't execute, it doesn't do anything before you tell Quill to properly execute that. This code will be compiled, it will generate the string, but that won't actually touch the database. That's what makes Quill so light, because you are never touching the database until that specific moment, right? When you do that, that's what we have. This is the experimental one. You can like turn it on and use Eclipse, that Eclipse feature to verify, and suddenly it doesn't compile anymore. It doesn't happen all the time. You have to do it by yourself. You have to go and turn on a specific bit to say, okay, use this experimental feature, because in that case, you actually have to go to the database to verify if that SQL is valid. However, sorry. In the day job, I don't know, I cannot say that people use that or not. It's an interesting feature. You can use that to validate your query at any time. But at least it makes a really good example. It's just like save lives. So basically, those are the main functionalities. I believe I started coding Scala mainly because I like to have tools that actually help me. And maybe I'm getting old, but I like to think I'm getting wiser. But I don't have patience to handle these giant tools, these things like, I don't know, Spring Boot, that's pretty much just a wrapper around Spring, right? Or Hibernate. I don't want to solve that giant problematic things. I want to handle like these small services. That's how I work nowadays. And I believe you should pick up the proper tool to deal with your problems. So a tool that's like that simplistic, a tooling that allows me to handle my database without thinking about SQL in general, more or less. That's not exactly true, right? That's the tool to go when you are thinking about microservices in this sense. one of these days I was discussing the use of Quill with a pair for my company, and the guy came up with one of that queries that usually used to generate like sailing reportment, like that sales reportment that they're like extremely complex, and they use like all that functions that no one knows that exists, right? Like window and these sort of things that are quite specific. I wouldn't say that Quill is exactly the tool to do this sort of thing. I still believe that if you have to do something like that, SQL is still the way to go. If you go to the our what's it called? I forgot the name. Gitter. Yeah, Gitter, where the discussion keeps going about Quill. You see a lot of people trying to do things that are quite complex, but not in the same level of people that create reports, if you know what I mean. So then again, like have in mind that it's a tool to solve problems in smaller contexts. If you're considering like microservices, if you're thinking about something that's simple, too complex, mid-term complex problems. But then again, if you have to do magic with your SQL, I don't think that's a tool that will actually help you out. Maybe you can reproduce that, but probably be extremely complex composing functions and everything else. All right, second, I'd like to invite every single one of you guys to have a look at the code. The tool keeps growing, so we have more and more people using, which means we have more and more bugs because people try to use it like in really different, interesting ways. We have interesting modules going on. Some of them I've never touched because I've never worked with Cassandra, for instance. So we have Quill working with MySQL and Postgre, Cassandra. There's OrientDB. I've never seen that before. SQL Server, my implementation, and many others. We keep getting like requests from people. There are some sort of issues like asking to implement it to handle, let's say, MongoDB. Seems a bit complicated to me, but could be a possibility. So if you are like a great MongoDB developer, please join us, and you can work on that one. And besides, personally, I enjoy working with something that I don't do on my everyday life, like on our everyday job. Usually, we won't work with these sort of things. Important to say, Quill has like a lot of macros, a lot of like low-level code, so it's always a really interesting challenge. It's well tested. It's really attractive. It's quite complex. What attracts a lot of people. That's what attracted me as well. So you are all invited to contribute, to be part of this community and make this tool keep growing. And oh, that's done. Oops, no. Okay, oh no, that's fine. Sorry. That's exactly what I had to show you guys. And yeah, that's just out of order. Thank you very much for this opportunity. I really enjoy talking about these tools. I think they're great. I enjoy them, and I love to have more people contributing because we have like a lot of bugs nowadays. And what's awesome, just proving that people are using that more and more. So thank you very much. If you want to talk to me, just send me a message. And I believe we have some time for questions. It's really weird to talk when you don't have like people talking back, like, so it's difficult. Oh, I already have some questions here. Okay. Okay, so the first one is, how is the SQL lang mapped to Scala lang structs, and does it support full SQL standard? The SQL language, it's a well-structured language, right? So considering that, you can represent that in many different ways. It's like if you think about, I don't know, Git commands, for instance, you have a well-defined way to structure your commands. So you can represent that in like in a regex, for instance. If you can do it with a regex, you can do the same in using ASTs, right? The abstract syntactic trees. So what happened is, based on the SQL language, we kind of extract that principle, like the standards, and we can represent pretty much almost everything. Not, I wouldn't say absolutely everything, but a big set of the structure of the SQL language. Given that, if we can do this, like using this structure of objects to represent that, we can reevaluate that and generate something else. But we just can do it because the language is well structured. So what we do is, like, through the quotation, we generate that flattened forgot the word. That flattened structure that will generate the SQL code because we are following the SQL code. So the structure is based on the SQL code initially. I said it's doing the same question. It says if support full SQL standard. I know it doesn't support full SQL standard because some time ago I started implementing the feature having, right, like group by having, and then we realized that having is like way bigger, way more complex than we were expecting the first moment. So I know that we don't have having, so having is not implemented yet. At the same time, not thinking about exactly having, but sometimes you can inline some SQL. You can, I mean, it's not like you just write the SQL, but you say, okay, I'm inlining that. You have a method that will allow you to add some specific things over there. But no, it's fair to say we don't have the full standard SQL yet, because some of them are more complex than we had in mind in the first moment. So we are almost there. Maybe if you know very well how group by having should be represented, maybe you can help us with that. Evalda, should I carry on with the questions? Want to say something? Valdes?
Yeah. Yeah, thank you. There's one more question I pasted to you, if you see. About...
Yeah. Oh, no. I'm getting the return again, please. All right, okay, thank you. So, the second one is how to avoid defining permutations with another query. For example, when having multiple sort criteria on diff fields and directions based on some params.
Is the question clear enough, or?
It's basically what? Can you repeat that?
I mean, we can leave that for offline, because I think you're almost finished the time.
Okay.
I mean, yeah, it's up to you. It's up to you. You don't need to answer now.
Okay, this one is actually so
Okay.
we can try to log in and answer later on, but like
Okay, sure. Okay, so thanks for your time. It was interesting to listen for the kind of a backstory and how Quill works under the hood.
Thank you very much.
All right, thanks.
Then again, if you have more questions, if you'd like to discuss or suggest something, anyone, send me a tweet, let's talk about it, and let's improve the tool. It'll be awesome.
Okay, thank you. Cheers.
Thank you very much.
So, I don't know, Ruslan, do you want to straight away give your thought? You kind of have time, but depends on you.
Questions?